Okay, so this week we're going to follow up a little bit on introducing the basics, and in this case we'll go through a couple of multi-part exercises that cover a few more tools that will hopefully reveal a little bit more about how lists work and how data trees work in Grasshopper. And in this little exercise, what I'll do is introduce the graph mapper, the range, and the remapping of numbers in order to just give us a little bit of control over a bunch of lines on screen. Okay, so I'm just going to head over to the, once again, over to the vector tab in the grid box here. We'll grab another grid, right? And eventually we'll move away from these grids. Actually, what I'm going to do is I'll choose another rectangular grid. Doesn't really matter. And I'll go ahead and put in a couple of values into the inputs here that it needs. So I'm just going to put a unit value of 1 into the spacing once again just to get us started, and then maybe I'll just copy and paste that panel out and just make a grid of 25 by 25 is fine. Right, and we know from the last exercise that that gives us a bunch of points, and it gives us a bunch of cell outlines, which we won't use for now. Also in the last exercise we noted that we flattened this data, and really what we wanted there was all the points to sort of act like a one single field of points versus a set of columns or rows. In this case, we're going to do something of the opposite, because what we're going to end up doing is drawing new lines in the same organization that the points are currently in. So let's take a look at that really quickly. I'm going to hide that. So we have a set of points here, and if I hover over, you'll see the kind of data structure here. So it looks like we've got 26 overall um, paths, and we have 26 items on each one. So we have 26 overall lists, and we have n equals 26, which is the actual points. So overall we have 676 points that are organized into 26 different lists. And this is coming from this information here. So let's take a look at how it's, which way it's organized. It can either be organized up and down, or in columns, or it could be organized back and forth here like that in rows. So to just give it a test, what I'll do is I'll go to curve, I'll grab a spline here, and I'll go to polyline, and I'll just plug that in. Now if I turn off the preview of the points, what you'll see is a bunch of lines in vertical lines that are parallel to one another, so that we know that the points themselves are organized in columns. And the reason why I drew separate lines, separate polylines, was because, once again, the points themselves are organized as such. So what this component is going to do is draw a polyline through a grouping of points for each one of those sets of points. So it's going to draw a different line for each one of those sets. And you can see here that I've got 26 lists again, but in this time n equals 1 because we're only producing a single polyline for each one of those lists of 26 points. Now if I go over here and I flatten this, you can see now that I've created a single polyline, and it exhausts the entire data set. So it's going to go up and down into one line, and basically make a connection from the last point of each one of the lists to the first point of the next one, and so on and so forth. Okay, so by default, sometimes it's very useful to work with the data structure that Grasshopper gives you, and sometimes it's useful not to. So we can explore that topic as we move forward throughout the semester. We don't need these, so I'll delete those, or you can turn them off. Yeah, I guess we can use that as well. All right, so let's move forward a little bit here. I'm going to go over to the parameters tab here and grab, under input, the graph mapper. It's going to look like a box here that's empty, and we'll work with that in just a second. What this is going to do is basically it's going to allow us to remap a set of values, a set of numbers. Similar in a way to how the control point, as you might remember, the little attractor point, similar to how the attractor point remapped a bunch of distance values for us. It allowed that we allowed that to be interpreted as a set of radii for circles. Something like this can happen also instead with a graph type. So we can right click on that and we can select a certain graph type. And we'll leave it at that for now. I select the Bezier for now. We have to give this a range of numbers. A single number won't really do anything for us, so we have to give it more. So one thing we want to do is make sure that we're always working within the range of geometry that we have. So we're going to go to list, and we'll grab this list length component here. We want to know how long each one of these lists are so we can act on them. Then I'm going to go to sequence, and I'll go to range. Move that over a little bit. The domain here we can leave between 0 and 1 because by default this component works between 0 and 1, which could be changed. But we're going to do it different. We'll do something else to make changes to that in just a moment. And since Grasshopper is 0 indexed, one thing we have to pay attention to is how many things we're getting out of the other end of this, right? So if we take a look, again, hovering over, we see that we have n equals 27, which means we have 27 values because of this input of 26. We want to get rid of one of those. We don't want this to have 27 values that we're going to apply to 26 points. That'll give us one extra data point, which is undesirable. So we're just going to simply right-click on this n input here. We're going to give it an expression. You can just hover over that area there and just type in x minus 1. Right, so that's just going to take all the inputs in and subtract 1 from it. So it's basically going to take 26 and turn it into 25 so that in the end we end up with the right number of values. And then we can go ahead and plug that direct into the graph mapper. One thing we can then do, I suppose, is take a look at the values that we have coming out, just to kind of get a sense for how this thing might work. And then if we go ahead and start making some changes to the actual shape of the graph here by dragging the little control points that are on screen, you can see that those values are updating and they're changing accordingly. And it's essentially remapping these numbers between the boundaries that we set up for it here, between 0 and 1, and giving us a good amount of kind of visual control over that value set. So I'll just go ahead and leave that there. We can leave it there just for good measure. Now the last thing we want to do is start to apply this to something on screen. Okay, so we're going to use that to kind of like shift the points around and to create a different pattern of lines. So basically to kind of like distort the grid. So let's do that. What I'll do is I'll go over to math, the math tab up top, domain, and you're going to find this remap numbers component here. Let's grab that. We also need a construct domain component, so we can construct the kind of value set that we want to basically bound that within. All right, so we're going to set a max and a min essentially, and I'll just grab another panel here just to show the values that I'm going to use. They could obviously change. Just make it between 1 and 10. So I now have a domain between 1 and 10, and I'll put that. Basically, that's going to be my target. So basically, I'm now going to put the result of the graph mapper into the values here. The source domain is by default 0 and 1, which is fine. We don't have to make any changes to that because, again, by default, this graph is going to work within that boundary, within that domain range. But we're going to force all of those numbers to have a new domain, but keep their proportional relationships to one another. So basically, we're just going to be increasing the effect that they have on the grid that will distort. All right. So let's go over to transform, and let's grab a move component. All right, I'll just move some things around. What we're going to be moving is the points, so those show up again. And then we just need to give this a direction. So we're going to use these values, but we need to tell it which direction to move in. So we can just go over to vector, the vector box here, and in this case we'll just choose the unit x. And now I can put my result of the remapping into the kind of f input of the vector tab there, the vector component, excuse me, and go ahead and place that output into the t input of the move. And what we can see is that we've already made an effect on the location of those points relative to the graph mapper. Right. So as I make some changes now to the graph mapper, we can see that we're affecting the grid accordingly. You can go ahead and play with the different graph mapper types. We'll get to that in the end. Okay. Now, what's interesting about this, I guess, is that we've maintained the throughout. We've maintained the data structure. We've worked with this as our sole input, basically, into both the the numeric values and also the geometry that we're actually working with. So we can see that things match up pretty nicely, right? We've got 767 points, and of course we have 767 move values that are related to that, and it's all the two data trees match up perfectly. That allows us to draw new sets of curves or new sets of polylines to this if we like. So let's go over to curve. I'll go to spline this time and just click interpolate, grab the interpolate component here, and go ahead and plug that in direct. Turning off the move component, then we'll just reveal the lines themselves, and we can see that we're now drawing a set of parallel lines in a different way, and we're able to control their, their overall form using the graph mapper. Again, if I go ahead and then flatten this, we're going to end up back where we started, basically, which is not really the effect we're looking for here, right? So in this case, it's an advantage to keep the default tree structure that Grasshopper kind of develops oftentimes when we're producing, a multitude of items coming out of a single component. So go ahead and right-click. You can change the graph type if you like, just to get a sense of it, and you can play around with that. All right, and this really, the point of this really is to just kind of demonstrate again a couple components that you might find useful, especially when it comes to prototyping certain kind of things on screen. These are really, they're sort of imprecise in a way because they're visually controlled, but at the same time, we do have numeric output that we're dealing with, and it's actually quite fast and intuitive, if you will, to make changes to your set using something like this. The other thing is the range component is very useful. And we'll walk through a couple different examples of that throughout the term, and we're also, we may probably refer back to this a number of times as well. So remapping in a couple different ways here. Later, in a later exercise part of this sequence, we'll show a different relationship between this remapping and the graph mapper. Okay, that is all for this one. We'll carry on with part 2.